All right, algebra, this is lesson 3.1. It's called functions. We are going to discuss input and output. You have learned this before. You just may not recognize it, I guess is the best way to say that. So you can see here, we've created an input-output table. All the input values are your x values, 1, 2, and 3, and your output values are the y values. Look up on the screen real quick for me, real quick. When you see the ordered pair, which one of these is the x value and which one's the y value? Sure. The 1 is the x value and the 3 is the y value. Very good. When you're dealing with functions, the key thing to remember is for every input, you have to have an output. And you can see here how they've graphed it. Okay. These all turn into an equation, y equals mx plus b. Okay. You don't really have to write any of that. So I'll give you just a second. I think you guys are writing your vocab words. I'll give you just a second to do that. All right, so tell me what the definition of a relation is. Chloe.
A period of inputs and outputs.
Yeah, so the biggest thing when you're talking about relation is you're going to be pairing x and y values. If I put in this input, it's going to give me this output. That's showing a relationship. Somebody tell me, what is a function?
A relation pairs each output with exactly one output.
Okay, so the key there is exactly one output. A function can only be a function if you have one output for every input. So that's something you do need to make sure you understand. You'll get it as we go through. All right, these are vocab words that you need to write. Domain, range, independent variable, and dependent variable. Do you have all those? Okay, I'll give you a minute. If you don't remember the definition for ordered pair or mapping diagram, add those to your... Example 1. Hold on, my face didn't come with me. All right, so we're going to determine whether each relation is a function. What's our rule about a function?
A relation pairs each input with exactly one output.
Each input has to have one output. So if I look at these coordinates, -2, 2, -1, 2, 0, 2, 1, 0, and 2, 0, would you say that each input has an output?
Yeah.
Correct. So then this would be yes, function on your paper. As long as you label it, we're good. What lesson?
Okay.
All right, so let's look at the next one. We have 4, 0, 8, 7, 6, 4, 4, 3, 5, 2. Would you say that every input has an output?
Yeah.
An individual separate output?
Yeah.
Look at my input values. What do I have?
4, 8, 6, 4.
Did we already say 4?
Yeah.
Can 4 be 0 and 3?
No.
So because the 4 has two different outputs, this one is not a function. So you have to have individual outputs for every input. Now you can have two different inputs equal the same output, but all of your x's have to be unique. Your y's can...
I get it.
No, all of your y's have to be unique compared to the x's. All right, so let's look at this one. -2 is 3, -1 is 4, 0 is 5, 0 is 6, 1 is 7, 2 is 8.
No.
Not a function.
That's 2 0.
You can't have two inputs having two different outputs. So not a function. All right, and the last one, -1 is 4, 3 is 15, and 11 is 15.
Yeah. Well, yeah, because the x's are different. So the y's
Correct.
can change.
So true, it is a function. Good job. All right, any questions on that so far?
Okay.
All right, go do your try-its. You have, oh, sorry, monitoring progress. You have 4 of them. Okay, so another way to determine whether graphs are functions is to do the vertical line test. A vertical line test is if I plot all my points and connect them, if I draw a vertical line anywhere, does it cross twice on the line that I drew? So for instance, if I drew this line, sure it plateaus, but does it cross the line anywhere but one time? It does not. Whereas this line, it crosses, if I draw a line vertically, it crosses the line twice, correct? So then this would be not a function because I'm going to have 2 y values for the same x value, which we already discussed can't happen, correct? Whereas this one, I may have the same x value, but they all have different. Am I saying that backwards? I have different x values with the same y value. There it is. Okay. So let's do example 2. So you're going to determine whether each graph represents a function and then explain yes or no. So if I look at A, I have dots everywhere, don't I? Do I have any x values that have 2 different y values? Yeah, I do have twice. The 2 is 2 or a 5, and the 5 is a 1 or a 5. So would this be a function or not a function? Not a function, because I have to have individual separate ones. I could also draw a vertical line and connect 2 dots. Okay, so now let's look at B. Can I draw a vertical line and connect more than 1 dot?
Yeah. Oh no,
No, it's a beautiful rise over run, gentle slope up a hill. If I draw a vertical line anywhere in here, I'm only hitting the line 1 time. So this would be a function. So you could say yes, function. Okay, so simple graph test that you can do if they've given you a graph. Excellent. All right, 5 through 8. All right, so let's talk about domain and range. Have you ever heard of those 2 words? Yeah? Good. So the domain, tell me what, before today.
Oh, yeah.
Okay, just making sure. I was like, they wrote vocab. So somebody tell me what is the definition for domain. Go ahead, Chloe.
The set of all possible input values of a function.
Right. So any number that I can put as an input would be counted in the domain. If they've given you a list, then it's all the x values, right? Okay, what is the range?
The set of all possible output values of a function.
So it's all the output or y values. They made this cute little machine here. You can see all the input values go in first. Those are your domain values. They have a function that they're doing, which is your equation, y equals mx plus b. And then you're going to get an output value or y. Correct? So let's look at this. It just looks like a lot. It's not that bad. Example 3. So we're going to find the domain and range of the function represented by the graph. So looking at A, these are not connected dots, right? They're just 4 little dots. So can I find the x and y values for each of these dots? Yes, so you're going to find the ordered pair for each of those. So what would this first one be? -3, -2. What would the second one be? -1, 0. This third one? 1, 2. And the last one?
3, 4.
Very good, 3, 4. So those would be your ordered pairs. And then it says identify the inputs and outputs. Now you can see they labeled them like this. You can also just say this list right here. I prefer this. The domain, which is all of your inputs. So domain, and then you just list them. You can also do D, capital D equals, and then list them. Did you hear me? Okay. So the domain is -3, -1, 1, and 3. And then what's the range?
-2, 0, 2, 4.
Right. So all the y values are the range. All the x values are the domain. Questions? Okay, so let's look at the second one. Now you notice this one is connected by a line, right?
Yes.
Just take notice of that. There's something you need to know about that. So when you have it connected by a line, it's everything in between here counts as part of the domain versus part of the range. So the domain is going to be the x values between the lowest x, which is what? X. Negative 2. You're right. You got me. That's me. And your highest value is 3. So the x values is everything between negative 2 and positive 3. What about your y values? So look at the lowest y value.
-1.
And your highest y value.
2.
2. So then you would write it such as this. The domain is your lowest number, and it has to be greater than or equal to that, all the way up to the highest number, which is 3. Negative 2 is less than or equal to x. So x is greater than or equal to negative 2, all the way up to less than or equal to 3. Okay? And then the range is from the bottom of the range, which was negative 1, and you put the y in the middle. Make sure you put a y because we're talking about range now. And it's everything in between the negative, including the negative 1 and the positive 2. So when you see a line on a graph, you're going to give me answers that look like this.
Is it always going to be greater than or equal to?
Yes, because it includes the, now, well, if the dot were an open circle, then it would not be.
Okay.
So, but right now the dots are closed. I don't think they introduced the open circle dots this lesson. All right, questions on this? Not too bad, right?
No.
I hope that was recording this whole time.
Oh.
It seems to have been. All right, so monitoring progress 9 and 10. Go team, go. Let me click on it and see. Our last example. All right, so real life world. I can't ever say that. Real life world problem. Word problem. Word. It's fine. My brain. All right, so we're going to use this in something you could actually use in real life. They give you the function y equals negative 3x plus 12. You hear the word function there, right?
Yes.
Okay. What does that equation look like?
Y.
No, but is there another thing I call that?
Y equals mx plus b.
Correct, which is the slope of a line. So you'll notice functions start out beautiful, looking like the slope of a line, which means it's going to be a nice either positive or negative. Eventually, though, your functions start doing funny things, just so you know. Anyhow, this represents the amount y in fluid ounces of juice remaining in a bottle after you take X number of gulps. So it's tracking how much Gatorade you're drinking every time you gulp. So we're going to identify the independent and dependent variables. Ooh, some statistics for you. An independent variable, do you guys remember that definition?
Yes.
What is the definition of an independent?
Variable represents input values of a function.
So it's kind of like the input value is the thing that's changing. So I am going to do something every so often. What is the dependent variable?
The variable that represents output values of a function.
Right. So the output value is not something you can control, is it? You can control the input. I can decide how much Gatorade I'm going to drink per gulp. But the output variable, it's dependent upon what you're doing with the input variable. So there's how I remember it. Which of the two things depends on the other one? So that's how you remember the dependent. The amount of fluid left in this Gatorade bottle depends on how much I drink per gulp. Does that help?
Yes.
All right. And then the domain, what is domain? X or Y? So it's 0, 1, 2, 3, 4. So we're taking up to 4 gulps. And then so it's asking you what the range is. So we're going to plug in these domain variables and solve for the range variables. So you can make a table to do this, and then you'll know the answers. So it already listed the input variables it wants us to do, 0, 1, 2, 3, 4. And then we'll plug in the output. So we're going to plug in 0 where on our equation? Yeah, where the x is. We're going to replace the x with 0. So we're going to say negative 3 times 0 plus 12. What's negative 3 times 0?
0.
Plus 12?
12.
All right, so you started with 12 ounces of Gatorade before you started gulping. All right, now we're going to plug in the 1. So you have -3 times 1, which is
Negative 3.
plus 12.
Positive 9.
Positive 9.
So you drank 3 fluid ounces, and now you have 9 fluid ounces left in the Gatorade bottle in one gulp. All right, 2 gulps. So -3 times 2
Negative 6.
plus 12.
6.
Now you only have 6 ounces of Gatorade.
9.
Yep, we plug in the next one. We have
3.
9 plus 12 is 3.
Last one is 0.
And the last one, you drank the whole bottle. 4 gulps. You were very thirsty after winning the soccer championship. Good job. Woo-woo. Okay,
I get it, miss.
understand. All right, so then the last question, make sure you always go back and read. It says, what is the range?
12, 9, 6, 3, 0.
So you would say R equals 12, 9, 6, 3, and 0. Capital R, not a lowercase, just to be clear. Lowercase stands for
Radius.
yes. So we got to make sure we're using the correct things.
Pi equals R times
Very good.
square.
I think that's it. So you have 11 and 12 and you're done.
Thank you, miss.
Good job, guys.